Hey guys, this is Gurjap. Welcome to our channel, and from today we are starting off calculus, and the first chapter of calculus is continuity and differentiability, and the first topic of this video is continuous function. So function f of x is said to be continuous at a point C which lies in its domain if the limit of this function at this point C is equal to the value of this function at this point C. So limit of this function at point C is given as limit x approaches to C f of x. It should be equal to the value of this function at this point C, that is f of C. If we reach this conclusion for any function, we say the function is continuous, but where? At this point C, at C. For example, say we have a function f of x is equal to 2x minus 3. We need to check its continuity at say x is equal to minus 3. So limit x approaches to, इस केस में c क्या अपने पास -3, so limit x approaches to -3 f of x is equal to 2 into -3 which is equal to -6 -3 which is equal to -9, and f of c, that is f of -3, will be equal to 2 into -3 which again is equal to -6 -3 which is equal to -9. So in this case, limit x approaches to c is equal to -3, f of x is equal to f of c. So this function will say it is continuous at x is equal to -3. Okay, now the next example is we are given a function fx is equal to 5x minus 3. We have to check its continuity at 0 and 5. So at x is equal to 0, limit x approaches to 0, f of x is equal to 5 into 0 minus 3 which is equal to -3, and f of 0 will be equal to 5 into 0 minus 3 which is again equal to -3. So for x is equal to 0, limit x approaches to c, f of x is equal to f of c. So it is continuous at x is equal to 0. Now for 5, limit x approaches to 5, f of x is equal to 5 into 5 minus 3 which is equal to 25 minus 3 which is equal to 22, and for f of 5 we have f of 5 is equal to again 25 minus 3 which is equal to 22. So in both cases, limit x approaches to c, f of x is equal to f of c. So this function is continuous at both x is equal to 0 and x is equal to 5. Now in this example, we have to check the continuity of this function f of x is equal to 1 by x, where x is not equal to 0. Now we are not given a point of continuity. If we are not given a point of continuity, then the function is said to be continuous if it is continuous in the whole domain. Okay, so what we'll do, we'll say suppose there is a constant number or a number c. We'll check its continuity at the point C, okay, no value. So at limit x approaches to C, f of x will be equal to 1 by C, cool. So the value of this function at this point C will be equal to f of C is equal to 1 upon C. Now in both cases, we'll take any constant number C. We are given x cannot be equal to 0, so we can take any number from its domain, and we have checked its limit at C, and we have also checked its value at C. Both values are equal to each other, so we'll say this function is continuous. Function is a continuous function. At what point? At every point except x is not equal to 0. Now next example is we have to check the continuity of this function fx is equal to 1 by x, where x is not equal to 0. Now we are not given a point of discontinuity, so we'll suppose a fixed number c, and we'll check its continuity at this point C. Now C can be any number from its domain, so we'll check its continuity on the whole domain, implies the function is continuous. Okay, so limit x approaches to C, f of x will be equal to 1 upon x क्या बन जाएगा 1 upon c, and its value at this point C will be equal to f of c is equal to 1 upon c. So in both cases, the value is equal to one another. So limit x approaches to c is equal to the value of this function at this point c. So we'll say the function is continuous. That's it. The function is continuous. At what point? At every point in its domain where x cannot be equal to 0. Now in this example, we have to check the continuity of f of x is equal to x mod. Now x mod or f of x can also be written as x mod is equal to x mod की दो values होती है minus x if x is less than 0 and positive x is greater than equal to 0. This is how the modulus of x works. Okay. So we have to check the continuity in two cases. First one, say if we check its continuity at c which is less than 0. Okay. In this case, f of c will be equal to, when x is less than 0, that is c is less than 0, f of c will be equal to minus x or minus c. Cool. Next point, we'll check its continuity or limit x approaches to c negative, that is left hand limit. Left hand limit कहाँ होगी? यहाँ पे. So f of limit x approaches to c negative, f of x will be equal to minus x which is equal to minus c, limit x approaches to c negative minus x which is equal to minus c. So in this case, limit of this function is equal to value of this function at this point c. So it is continuous for all negative numbers or negative real numbers. Now we'll check its continuity for all the positive real numbers. So in case of positive real numbers, that is c greater than 0, the value of this function will be x. So f of c will be equal to c, and limit or right hand limit x approaches to c positive, f of x will be equal to what? X. That is limit x approaches to c, x which is equal to c. Now in this case, limit is also equal to the value of this function at this point c. So it is continuous for all positive real numbers. Okay. Now it's continuous for negative real numbers, continuous for positive real numbers. What about 0? In case of 0, what we'll do, we'll find its value for c less than 0 or c greater than 0, that is, we'll find its left hand limit and right hand limit. So for left hand limit, limit x approaches to c negative, f of x will be equal to minus x, और इसकी लिमिट क्या होगी? c should be, हमने 0 पे निकाल लिया है, तो c की वैल्यू क्या आ जाएगी? 0. So its limit will become limit x approaches to 0 negative which is equal to minus 0 which is equal to 0. ये आ गई इसकी वैल्यू लेफ्ट हैंड लिमिट्स फॉर 0. सेकेंड इज राइट हैंड लिमिट. सो राइट हैंड लिमिट इन दिस केस will be equal to limit x approaches to 0 positive f of x which is equal to limit x approaches to 0 positive. इस केस में कौन सी वैल्यू आएगी? सिर्फ x which is equal to again 0. So left hand limit and right hand limit for 0 are equal to one another, and the value of this function directly put will also be equal to f of 0 is equal to 0 for both the cases. So the function is continuous for all the points in its domain. Now for the next example, we are given a function f of x and we have to check its discontinuity. What is discontinuity? We know a function is said to be continuous if it satisfies this condition. If in case limit x approaches to c, f of x is not equal to f of c, then we say this function is discontinuous at point c, and this point c is called the point of discontinuity. So we'll check its continuity at a number which is less than 1, then a number which is greater than 1, and then for a number 1. So for a number c which is less than 1, the value of this function f of c will be equal to c raised to power 10 minus 1, and its limit, that is limit x approaches to c negative, f of x will be equal to again what? C raised to power 10 minus 1, 10 minus 1. So clearly it is continuous for all c less than equal to 1. Okay, sorry, less than 1, not equal to 1 in this case. Now secondly, we find its continuity for all the numbers which are greater than 1. So for c greater than 1, the value of this function at c will become x square, that is limit, c square, and its limit x approaches to c positive, f of x will be equal to c square. So limit is equal to the actual value, so it is continuous for all c greater than 1. It is continuous for a number less than 1, continuous for a number greater than 1. What about the number 1? So, at 1, we'll check its continuity by using left hand limit and right hand limit. So, at left hand limit x approaches to 1 negative, f of x will be equal to what? X raised to power 10 minus 1, that is x limit x approaches to 1 negative, x raised to power 10 minus 1. But we are using c as a constant, so we'll use x approaches to limit x approaches to c negative f of x, it will become c raised to power 10 minus 1. Okay, the right hand limit will become limit x approaches to c positive, where c is equal to 1, f of x is equal to c square. Now the left hand limit is not equal to right hand limit for a number c equal to 1, so it is discontinuous at this point c, and the point c is equal to 1 is called the point of discontinuity for this function. Now the next topic is differentiability of a composite function, but before that let's take a quick recap of differentiability. Now in class 11th we studied what differentiability is. The derivative of a function f of x at a point c is given as limit h approaches to 0 f of c plus h minus f of c divided by h. This is how you give derivative of a function at a point c, and the identity f dash x is equal to limit h approaches to 0 f of x plus h minus f of x divided by h is called derivative of the function f of x with respect to x. This is quick recap for differentiability. Next point is the algebra of differentiability. We also denote differentiability f of x by d by dx of f of x or capital D of f of x. Now, algebra of derivatives say that differentiability of two functions, say u and v, in addition and subtraction is equal to derivative of first plus or minus derivative of second, and in case of multiplication we use the UV rule. UV rule says that if two functions are in multiplication, their derivative u into v will be equal to u into derivative of v plus v into derivative of u. And if these functions are in division, then in that case its derivative becomes v u into derivative of v minus v into derivative of u divided by v square. Okay, cool. So we know everything about differentiability from last time. Let's talk about differentiability of composite functions. So what is a composite function? Say we have two functions v of x and u of x. If one of these function is dependent on the other function, their combination is said to be a composite function. For example, if I have a function 2x plus 1 square, okay, and I can write v of x as v of t in the form v of t is equal to t square, where t is equal to u of x is equal to 2x plus 1. So in this case, the v of t is dependent on u of x. So I can write it as v of u x, that is ux is contained in v, or v of u of x. Such function is called a composite function. Suppose we have a composite function f of x is equal to v of u of x. Okay, now how do we find its derivative? We use chain rule. What is chain rule? Firstly, we'll put u of x is equal to t, and if the derivative dt upon dx and dv upon dt exist, then by chain rule, derivative of this function df upon dx will be equal to dv upon dt into dt upon dx. Okay, now this is quite difficult to understand like this, so let's take an example. For example, let's say we have a function 2x plus 1 square. Okay, so in this case, what is v of x? V of x is equal to 2x plus 1 square and u of x is equal to 2x plus 1. So first step was to put u of x is equal to t. So if u of x is equal to t, then v of x becomes t square. So by chain rule, df by dx will be equal to dv upon dt into dt upon dx. That is derivative of v with respect to t and derivative of t with respect to x. So derivative of v with respect to t will be equal to, now we know d by dx of x raised to power n is equal to nx raised to power n minus 1. Using the same expression here, we get dv by dt is equal to 2x and dt by dx will be equal to, dt by dx is equal to d by dx of 2x plus 1, which is equal to d by dx of 2x plus d by dx of 1. Now d by dx of 1 is equal to 0 and d by dx of 2x is equal to 2. So derivative of t with respect to x becomes 2. So final result will be equal to 2 into 2, that is 4 t, and t is equal to 2x plus 1. Using this value, we get 4 into 2x plus 1, which is the final derivative for this composite function f of x is equal to 2x plus 1 raised to power 2. Now next example is f of x is equal to sin x square. It is a composite function where u of x is equal to t is equal to x square. So v of t is equal to sin t. Now using the chain rule, derivative of f with respect to x is equal to d by dx d by dt of v into d by dx of t. Now d by dt of v will be equal to d by dt sin t. Derivative of sin is equal to cos, which is equal to cos t, and d by dx of t, that is x square, is equal to 2x raised to power 1. Okay, using these values here, we get dv by dt is equal to cos t into 2x. So using the value of t is equal to x square, we get 2x cos x square as a final result. So 2x cos x square is the derivative of this composite function sin x square by using chain rule. Now there is also an alternative method. Using that method, what we do here is we say f of x is equal to sin x square. So we'll find its derivative without using the chain rule. I find this method quite easy I find this method quite easy as compared to the chain rule. So d by dx of sin x square will be equal to, first step हम क्या करेंगे, derivative of sin x square with respect to x. Simply क्या होगा, sin का derivative क्या होता है, cos. So we get cos और इसके साथ क्या x square, उसको वैसे लिख दो x square. फिर फर्स्ट फंक्शन का डेरिवेटिव हो गया, हमारे पास x स्क्वायर भी बचा हुआ था, इसका हमने डेरिवेटिव नहीं लिया, तो हम क्या करेंगे, इनटू d बाई डी एक्स ऑफ x स्क्वायर. तो फाइनल रिजल्ट क्या आ जाएगा, 2x cos x square, which is equal to result. You can check. So this method is quite easy and short compared to the chain rule. Now this method is quite easy as compared to the chain rule. It depends on you which method you want to use. This कोई डिफरेंस नहीं है दोनों में, आंसर दोनों से सेम आएगा. ओके, नेक्स्ट फंक्शन इज साइन एक्स स्क्वायर प्लस 5, कॉम्पोजिट फंक्शन. फर्स्ट सबसे पहले हम क्या करेंगे, इसको चेन रूल से, देन द अदर मेथड दैट वी जस्ट टॉक्ड अबाउट. सो बाय चेन रूल हियर टी इज इक्वल टू यू ऑफ एक्स इज इक्वल टू एक्स स्क्वायर प्लस 5 एंड वी ऑफ टी इज इक्वल टू साइन टी. ओके कूल. फर्स्ट स्टेप, डी बाय डी एक्स ऑफ टी विल बी इक्वल टू डी by dx of x square plus 5, which is equal to d by dx of x square plus d dx of 5. Now this is equal to 0 and d by dx of x square is equal to 2x. Okay. Second point, we have to find derivative of v with respect to t. So dv by dt is equal to sin t d by dt, which is equal to cos t. So its value will become d by dx of f is equal to dv by dt into dt by dx, which is equal to dv by dt is cos t, dt by dx is equal to 2x. So we have 2x cos t और t की वैल्यू क्या है हमारे पास x square plus 5. So we have 2x cos x square plus 5. This is the result using chain rule. Now let's see the same question or same example with the help of alternative method or easy method. We can also call it direct method if you want to. So d by dx of sin x square plus 5 which is equal to, सबसे पहले क्या करो, साइन का डेरिवेटिव क्या होता है cos, उसको डायरेक्ट लिख दो cos और साथ में इसका एंगल वैसा ही x स्क्वायर प्लस 5. फिर उसके बाद क्या करेंगे, इसका जो एंगल है उसका भी डेरिवेटिव लेंगे. सो d बाई डी एक्स ऑफ एक्स स्क्वायर प्लस 5, डेरिवेटिव ऑफ एक्स स्क्वायर प्लस 5 क्या होता है 2x के इक्वल. सो वी हैव 2x cos x square plus 5 and hence the result. Next function is f of x is equal to cos of sin x. We'll attempt this example by using the direct method. You can also try it by using chain rule. So by direct method d by dx of cos sin x is equal to, सबसे पहले क्या होगा, डेरिवेटिव ऑफ cos ऑफ sin x. sin x इस केस में क्या है cos का एंगल. सो डेरिवेटिव ऑफ cos क्या होगा sin माइनस साइन, सॉरी cos का डेरिवेटिव क्या होता है माइनस साइन इंटू इसका एंगल sin x. फिर सेकेंड स्टेप क्या होता है डेरिवेटिव ऑफ दिस एंगल दैट इज sin x. नाउ डेरिवेटिव ऑफ sin x इज इक्वल टू cos x. यूजिंग दिस वैल्यू वी गेट माइनस साइन ऑफ sin x इंटू cos x और माइनस साइन माइनस cos x साइन ऑफ sin x. Next function is f of x is equal to cos of under the root x. So dx or derivative of cos under root x with respect to x is equal to, first point cos का डेरिवेटिव क्या होगा माइनस साइन. सो माइनस साइन इंटू अंडर द रूट एक्स दैट इज द एंगल. सेकेंड पॉइंट इस एंगल का भी डेरिवेटिव. सो d by dx of under the root x. Now d by dx of under root x can also be written as d by dx of x raised to power 1 by 2, and we know d by dx of x raised to power n is equal to nx raised to power n minus 1. Using the same rule here, we get 1 upon 2 x raised to power 1 by 2 minus 1, which is equal to 1 upon 2 x raised to power minus 1 upon 2, which will become 1 upon 2 1 upon x raised to power 1 by 2, which is equal to 1 upon 2 under the root x. So d by dx of under root x is equal to 1 upon 2 under the root x. Using this value here, we get minus sine under the root x into 1 upon 2 under the root x, or simplifying it, we can write 1 upon 2 under the root x sine under the root x with negative sign, and hence the result. So guys, this was it for today. We'll continue this chapter in the next video. Till then, keep practicing.